Erwin Schröedinger is an early 20th century Austrian quantum physicist. He is one of the first people to enter into the quantum realm and created the fundamental equation to describe quantum mechanics. He was dealing with truly one of the smallest things possible. These things were molecules and atoms. By exploring the seemingly unnoticed part of reality, creating his equation, and sharing his questions and theories, Erwin truly paved the way for future quantum physicists. Erwin Schröedinger was a pioneer of quantum mechanics. Erwin Schröedinger was born August 12, 1887, in Vienna, Austria. He was the only son of the owner of the oilcloth factory, whose deepest interest lay in painting and botany. At age 11, Erwin entered into the Akademisches Gymnasium, which is a secondary school that was founded in 1553. At age 19, he graduated and went to the University of Vienna. After 4 years of school, in 1910 he got his PhD with a dissertation on the conduction of electricity on the surface of insulators in most air.
In 1914 did something that's called habilitation. It's something like a second PhD that was needed at the time and actually still is needed in some countries in Europe to be able to become a university professor.
In 1918 to 1920, Erwin was an assistant at the University of Vienna, and in 1920 he became an assistant to Max Wien, a professor at the University of Jena. In 1921, he also married his wife, Anne-Marie Bertel. After 6 years, he became a professor of theoretical physics in the University of Berlin as a successor to Max Planck. 2 years in, he's elected to the Prussian Academy of Sciences. And then in 1933, Erwin wins the Nobel Prize, but also flees Berlin that same year due to the Nazi regime rising in power. But before he leaves, he made 2 amazing discoveries. Although Erwin had many discoveries, I will only focus on the 2 most popular he had, one being the Schrödinger equation, and the other being Schrödinger's cat. Schrödinger's cat was a theoretical problem that Schrödinger came up with. As the problem goes, you put a cat in a box that also has a radioactive atom and a flask of poison. Once the atom decays, the flask will break and the poison will kill the cat. The odds of the flask breaking increase over time, and eventually it will, but with how quantum mechanics work, the cat can be both dead and alive. In theory, by opening the box, you could kill the cat. If you open the box, you would force a choice to occur upon the atom of whether or not it is decayed, causing the cat to exit out of the superposition, which would either kill it or spare it.
And Schrödinger, now using this thought experiment called Schrödinger's cat, showed that the behavior of the micro world, namely the behavior of this radioactive atom, can be directly translated into behavior in the macro world, that is the world of our everyday experience.
Erwin did not intend for this experiment to become so popular, or to be taken as fact, but rather this was used to challenge the form of quantum mechanics that we use wrong. Schrödinger found this to be absurd that could be possible. The form of quantum mechanics that Erwin believed to be correct is a kind he made up called wave mechanics. Rather than believing in particles, he believed in waves. So Schrödinger named his fundamental equation for quantum mechanics the wave equation, although it works for both particles and waves.
And this wave equation of Schrödinger's is basically the same thing as Newton's equation of motion from his second law, from Newton's second law. You might have seen that already. It's F equals m times a. Force is mass times acceleration. And Schrödinger's equation is basically the same thing for microparticles, but it shows that in the micro world, things behave quite differently than in the world of our everyday experience that Newton described with his equation.
There are many modern technologies that we have today, and we don't even realize that Schrodinger's equation is behind a lot of them.
The Schrödinger equation is at the basis of many things. If a solid state physicist tries to describe how a semiconductor works, semiconductors make computers work, he will usually start with the Schrödinger equation.
Schrodinger's equation is used everywhere. It is used in physics and most of chemistry to deal with problems about the atomic structure of matter. It is an extremely powerful mathematical tool. Without it, there'd be no personal computers because we can't make a transistor, and no Blu-ray, DVD, or CD players as we wouldn't be able to make the laser. Computers were around before transistors, but they used vacuum tubes for logic. The more logic you needed, the more vacuum tubes you needed. This is why our computers no longer take up the size of a room, and we can have our own personal computers. As for the disc players, we would be unable to create lasers. Using quantum mechanics, we were able to stimulate photons in a very controlled area, allowing us to read thin lines of data.
He would frequently read antique texts. He would also be interested in Eastern mysticism, like Buddhism and many other things, Indian philosophy, and would be very open-minded about all these things. And I think this plays a big role in how he approached physics too.
Schrödinger was always looking for some evidence of a great power or something that created the universe. He looked through all of his research for patterns so he would have reason to believe. Erwin came up with the fundamental equation of quantum mechanics and caused people to question what they already knew. Erwin was not just a man interested in physics, but other things, especially philosophy. Erwin died January 4th, 1961, at the age of 73 in the town he grew up in. Erwin will always be known as a pioneer of quantum mechanics.